Yeah, last week's Ed Puzzle had our lesson. See, fortunately, I already had a recording of last week's lesson from last year that I was able to use for you guys. So that way you can still review everything, get the lesson, and get where you need to be. I see there's a few people that are starting to slip a little bit behind. Let me look at this. I saw some grades that slipped a little bit earlier when I was checking it out. So last week there's just two people. That's not too bad. Just two people that haven't finished last week's assignment, and already got people started on this week's assignment. So hey, all right, we're ready to go. So yeah, you guys are doing well. This is a good class. All right, well, we're going to get started, and those folks that are going to miss are going to miss, I guess. So because we've got a time is marching on. We got to boogie on down the road here. So let's put up on the screen, see what's going on with this week in Algebra 3. We go to our grade screen as usual. We'll see that we're at the end. This week we have the practice test and part 1 and part 2 of the actual test. So that's what's due. Now the practice test, let me remind you, is a practice grade, and you can take it as many times as you want to. It's set to unlimited tries because it's a practice grade. It doesn't matter. But you should use that to figure out, what do I need to study? If you take the practice test and you bomb the first 5 questions, that first 5 questions, I'm sure, are all on the first lesson. Back to arithmetic sequences. Means, I need to go back to the arithmetic sequences because I didn't do well. So maybe I want to go back and take those 5 questions again to make sure I got them right now. Because if I take the practice test a second time, maybe I'm not taking the whole test. Maybe I'm just taking the problems that I missed the first time, because I don't care about my grade in the practice test, right? Because it doesn't affect my semester grade. So maybe the second time you don't have to take the whole thing. Just go back and take the ones that you missed. Go back and look at those and say, okay, why did I miss that? Is there something I didn't understand, or did I just make a careless mistake? Hopefully it was just a careless mistake. Oh yeah, that was a negative. I missed that. Something silly like that. That means you knew what you were doing. You just had a careless mistake. So use the practice test for your advantage. And then that'll tell you when you're ready to take the test. So let's go take a look at the practice test. It has a whole lot of practice for it, a lot of questions. So we look at it here. All this, it's got 32 questions. And your questions may or may not match these that are here. In fact, I printed out this practice test. And when I printed out the practice test, I got different questions. So I'm going to work some of this practice test on paper. And like here it is. I've got it printed out. And look, this is a different question than what I just had on the screen. So I had on the screen here was 357. And this one's 258. So you may have different questions, but it's still the same type of thing. What's the 30th term of this sequence as compared to the 30th term of the other sequence? So I want to work some of these just so we can refresh our skills and remember how to do all of this good stuff. So I'm going to need my notes. Let's see, I've got notes on arithmetic series. Let's see what other notes. I have several notes piled up that I was using before. Let's get that out of the way. There's some geometric series notes. Recursive and explicit on sequences. There's that interest formula highlighted there. Here's some notes with arithmetic sequence, geometric sequence, arithmetic series, geometric series. Okay, so with all these notes, we can get on this. So what's the 30th term? So this is just lesson 1. Now, this used to be unit 8. It's unit 5 now. But this is from lesson 1. So for this arithmetic series, we don't know the last term, so I can't take the term before it and add 2 or add whatever D is. So I can tell that the common difference is it's adding 3 each time, right? 2, 5, 8, adding 3. And if I want to know the 30th term, I can use this explicit formula, which says a to the 30th equals a1. Well, the first term is 2 plus the common difference times n minus 1. Well, n is 30, so times 29. And that will give us the 30th term in the sequence. So let's pull out our calculator here. 3 times 29 plus 2. So we're looking for 89. 89 is going to be the answer. So a lot of this ought to be, as long as you got your notes, and if you haven't made notes, make notes now. Go back and hit those lesson summaries and make sure you have all these formulas written down, because that's what's going to make it real easy. I was just able to pull out this formula and go plug in the numbers and get the answer. So this hopefully will be you guys have done great on these assignments. So I'm very confident that you guys are not going to have trouble with the test as well. So Braxton loves to download new music. He originally had 41 songs. Okay, so that would mean that was the first term. But he plans to purchase 4 new songs each week. Common differences plus 4. He wants to know how many songs he'll have after 2 years, or over 2 years, 110 weeks. So he wants to know A110. So using the same formula up here, 41 plus our common differences 4 times 109 weeks, because it's n minus 1. I can do 41 plus parentheses. I'll put it in parentheses. 4 times 109. Close the parentheses. 477. Oh, it didn't even ask the answer. Look at this. It wants to know which equation would you use. Well, I've already set up the equation because I knew it from our formula. 41 plus 4 times 110 minus 1, 109. So this is wrong because you don't add. This is wrong because these are in the wrong place. That's not the first term. So, wants to know if you could set the formula up correctly. Number of visitors to a park is expected to follow this function. X is the number of days since opening. On the first day, there's going to be 32 people. What's the function that shows the total visitors? Well, we know it's A1 plus, right? The formula is A sub n equals A1 plus the common difference, n minus 1. Well, they're doing x minus 1. That's fine. So it would be, nope, that's minus 32. So that would be minus A1 when it's not minus A1. That takes the 32 and totally changes everything. That's way wrong. See, that is a minus. 32 plus 8. That's it, right? Plus, because this one has a minus. So it tells us that is the correct answer. So it's just identifying the correct response, the correct formula. All right, let's see. It did print on the back here, so I do the front and back. A new video game is expected to sell 100 copies the first hour. So that's our A1. After that, the sales will follow this function, where X is the number of hours, which shows the total sales. So this is just like the last problem. Which formula would do it? Well, we know it's 100 plus, and it's 12x minus 1. So which one is that? No, that's a minus. It's this one. 100 plus. What is the 32nd term? And this is still back to the very first lesson. 32nd term, where this is A1 and we have A13. So that allows us, well, no, we can't do this one because we got to know A12. Oh, we got to know the 31st term. We got to know the 31st term to add the common difference. So we still have to use this one, but we don't know the common difference yet. So we can use this one to work backwards. We know what the 13th term is, A13. So that is negative 59. If that's the 13th term, the first term was 13. We don't know the common difference, but we know that n minus 1, since this is the 13th term, would be 12. So we can work backwards to find D. Substitute everything we know. We know the 13th term is negative 59. So we know 13 minus 1 is 12, and know the first term. So subtract 13. So that's negative 72 equals basically 12D. So D times 12 is 12D. Divide by 12. D is negative 6, because negative 72 divided by 12 is negative 6. So now we could use that to know the 32nd term is the first term plus negative 6 times 31, right? Because that's n minus 1. So if we can solve this, that'll give us hopefully one of these numbers right here. 13 plus parentheses negative 6 times 31, close the parentheses, negative 173 right there. All right, so yeah, this arithmetic sequence thing, a lot of it's just making sure you have the right formula. Then it's just making sure you can put numbers in the right place. This one we actually had to find the common difference. This one will also be just like this problem. See that? 32nd term gives you the first term, and this one gives us the 9th term. So we can use this to find the common difference to get us to this. So again, we know the 9th term is negative 119. We know the first term is negative 31. We don't know the common difference, but since this is A9, 9 minus 1 is 8. So we add 31 to both sides. So let's do it in the calculator, not mess it up. Should be what negative 88 or something like that. 119 negative plus 31. Yep. Negative 88 equals 8D. So when you divide by 8, D equals negative 11. Negative 88 divided by 8 is 11. So now let's move this over here, set up our formula. A32 equals negative 31 plus, this is a negative 8 times 31, because this is n minus 1. N minus 1. Let's do the math in the calculator. Negative 31 plus parentheses negative 8 times 31, close the parentheses, it equals, that did not end up with the answer, not one of our choices. So let's go back and see where we've done something wrong. All right, so negative 119, negative 31 plus common difference times 8, because it's n minus 1, and we know n is 9. So added 31. We did this with the calculator. We know it's negative 88. Oh, there's what we did wrong. Look what I put in here. That's not a negative 8. That's a negative 11. I wrote down the problem wrong. I was thinking of these 8s over here, and I wrote negative 8 as our common difference, but it was negative 11. So I just did the whole problem wrong. So let's go back. There we go. So negative 31 plus parentheses negative 11. That'll make a big difference. Times 31. Negative 372. Yeah, we have that answer. All right. Yep. Careless mistake. That's what I was talking about. Sometimes you go back and you make a mistake. Make sure you're using the right number. I put the wrong number in there as my common difference. Careless mistake. We knew what we were doing, just did something silly. So that's what you got to watch for. So in that case, when I figured that out, I probably wouldn't need to go back and retake the practice test. It's like, oh, I know what I was doing. I did it right here. I just made a careless mistake. So as long as you know what you're doing, then you can feel good about going on and saying, okay, I'm so far I'm still ready for the test. All right, given the arithmetic sequence, and so here's our sequence formula. What is the domain for n? Remember, the domain is the x or the n. It's the term number, because n is the term number. So what term numbers can we have? We can have the first term. We can have the second term. We can have the third term. Can we have the 0th term? No, we can't have the 0th term. We can't have the negative first term. We can only have the first term, second term, third term, etc. So that means we can't have all integers, because that would include these. We can't have all integers where n is greater than or equal to 0, because we don't have a 0th term. All integers where n is greater than 1. Well, that leaves out 1. That means you start with the second term. That's not right. So it's all integers where n is greater than or equal to 1. Yes, because it's 1, 2, 3, 4, 5. And that never changes. That's always the domain for arithmetic or geometric sequences. Which means this one right here, just because we're using a different sequence, it does not change the domain. It's still greater than or equal to 1. Don't miss that one. That's a gimme. That's an easy one on the test. I'm sure it'll ask that, because it's asked it to us twice on the practice test. Oh, we've moved on to the second lesson now. What is the sum? Yeah, that was arithmetic series of a 54-term sequence. The first term 6 and the last term is 377. All right, well, let me see. Where is my notes on arithmetic series? Here they are. We had two formulas we could use for a series. One uses the first term and the last term. One just uses the first term and the common difference. Well, they gave us the first term and the last term, so we can use this formula right here. So 54 terms. So that's n. So the sum of the 54 terms would be 54 divided by 2. And then add the first and last term. 6 plus 377. And now we're ready for our calculator. 54 divided by 2 is 27 times, parentheses, 6 plus 377, parentheses. So it's 10,341 right there. First choice. First choice, 10,341. Okay. Let's see what's on the back of this page. These are just zipping right by. This is not going too bad. So I'll have this recording if you need to go back and review this. When you take the practice test, you may have different problems, like I said, and you can go back and just fast forward the video to whichever problem you need to look at and see how I did that. What's the sum? If there's 24 terms and it gives the first, second, and third. All right, first, second, and third. We have this formula, which just takes the first term and the common difference. Well, we can figure out what the common difference is. What's going on from here to here? What's going on from here to here? Well, let's see. 152 to 138, that's subtracting 14. 138 to 124, that's subtracting 14. So that's our common difference. So let's use this formula. 24 terms is 24 divided by 2 times 2 times the first term, which is 152, plus the common difference, which is negative 14, times n minus 1. And since n is 24, that's times 23. Good thing we use the calculator on this. We'd have to be spending some time doing some math on paper. 24 divided by 2. Okay, so we know that. That's 12. And let's figure out what's in the parentheses. 2 times 152. 2 times 152 is 304 plus, and I'll put this in parentheses, negative 14 times 23. Times 23 in parentheses. So this all equals negative 18. So we take that times 12, and it's negative 216. Hopefully that's one of our choices. Hey, perfect. Negative 216. Okay. Same type of problem right here. What is the 8th term of this geometric sequence for negative 20, 20? Or negative 20, 100, sorry. 8th term. So we can use basically the same formula. Let's just figure out what our common difference is here real quick. 4 to, oh, wait a minute. We've moved on. This is less than 3. This is geometric. Notice this is no longer arithmetic. So we need entirely different formulas there. Let's see. That's geometric series. That's when we're totally not. That's not what we want. Let's see. Well, I have this geometric sequence formula. First term times the common ratio n minus 1. Let me highlight that so I don't lose it. And I have that's the arithmetic sequence. And here's the series. Okay, just so those jump out at me. Geometric sequence. So let's figure out what's going on. If we're not sure what's happening here, we can just divide backwards. Let's take our calculator. I'll show you how to do that. Sometimes you can see it real easily. Sometimes you can't. So if we take 100 and divide it by negative 20. Oh, I hit 201. Put this up here. Divided by negative 20. That's negative 5. When we divide this, that's negative 5. Let's try it again just to make sure. Negative 20 divided by 4. Negative 20 divided by 4. That's also negative 5. So that is our common ratio. Each time it's negative 5. So using our formula right here, this one, a sub 8 is the first term, which is 4. Common ratio n minus 1. N is 8, so to the 7th power. So we can calculate that. Four times negative 5 raised to the 7th power. Right there. First one. All right. We're still on lesson 3 here. So Roberto has been studying a type of bacteria that doubles every month. R equals 2 times 2. Up 3 bacteria cells. Originally there were 3. So that's A sub 1. He wants to know how many is going to be after 43 months. N equals 43. Which equation should he use? Well, he's trying to figure out A sub 43. We're using the same formula here. A sub 43 would be the first times the ratio to the n minus 1. So the first was 3. So all of these have a 3. The common ratio is 2. All of these have a 2. The only difference is it times 43? Is it raised to the power of 43? Is it times 43 minus 1? Or is it raised to the power of 43 minus 1? Well, we know it's not multiplied by 43 or 43 minus 1. We know it's raised to the power. And this was n minus 1, right? That's 8. So if he's wanting 43, it's minus 1. It's this one. Not the 43. So that's the formula that would get him the answer. All right, let's move on. Number 13. This is another one where we have to determine the formula. What is the function? Okay, 3 times more. Every day there are 3 times more likes on an internet video of a cat, which is modeled by this function. Where n is the number of days since video is posted. On the first day, there was 143 likes, a sub 1. So what's the function that shows the number of likes each day? Well, we remember the formula is a sub 1 times r raised to the n minus 1. So this is 3 to the n minus 1, because that's the 3, so that works. And we need the 143 in front of it. Not 143 times that, not 3 to the 100 rate. That's all messed up. Raise the power of 143, raise the power of it. No. No. 143 is our first one. That's what. There it is. 143 is a sub 1. There's our common ratio, and there's the n minus 1. That looks exactly like this. That's our answer. They put some really weird ones up here. So hopefully you can look at that easily and go, that's not even close. All right, here's another one just like the one above it. 5n minus 1. Every day there's 5 times more, so that's our common ratio right there. The first day there was 103 likes. This is a video of a dog. N's the number of days. So this is a sub 1. So we're looking for the same type of thing. This has the 5. This has the 5 because that should have 103 is first. And this has the common ratio. That doesn't even use the common ratio. So again, process of elimination. That one's pretty simple. All right, let's go on to backside page here. Same type of thing. 3 in a row. The surface area of an oil spill gets 105% larger each day. Okay, so that's 1.05 as a decimal. Represented by the function. So they've converted it for us right here. Perfect. On the first day, 31 square meters. So that's a sub 1. Which function would do that? So we need the 31 to be the first thing. Well, we can eliminate them all real quickly. 31 times the common ratio, x minus 1. All right. Don't make these too hard. Look at that. If it looks crazy, cross it out. What is the 8th term of a geometric sequence? Well, here's the first term and here's the third term. Okay, so if we know the third term, we can work backwards and figure out the common ratio. So it'll be 16 equals, we can use this geometric sequence formula right here, a sub 1 r n minus 1. We know a sub 3 is that. The first term is this. N minus 1, if that's the third term, this will be squared. All right, let's solve for r. $256. 16 divided by 256. 16 divided by 256 is point. Oh, yeah, and they're giving us in decimals over here. So it's 0.0625 equals, these cancel out. So this is just r squared. So this is not the answer yet because this is not r. We got to take the square root. So r will equal the square root of that number. So here's the square root button. It's 0.25. 0.25. That's the square root. Oh, it doesn't have that. Oh, that's because that's just the common ratio. I haven't found the 8th term yet. Whew, I haven't finished. All right, so the 8th term will be the first term, 256, times the common ratio to the 7th power. using our formula. Let's do the math there. All right, 256 times the common ratio, 0.25 raised to the 7th power. So it is that one right there, 0.15625. All right, so we're working through the practice test. We're halfway through because this is test week. What is the 6th term? And they give us the first and second. So the second term is negative 125. The first term is 625. It's times r to the, well, if this is n minus 1, that's just r to the first power. So this one's going to be easy. Once we divide by 625, that will equal r. Because that's just r to the first power. (125) negative divided by 625. So this is negative 0.2 is the common ratio. So move over with the 6th term. So the 6th term would be 625 times 0.2 to the 5th power. Because remember, our formula is first term times the common ratio to the n minus 1. And since n is the term you're looking for, we're looking for the 6th term. So raising it to the 5th power. 625 times 0.2 raised to the 5th power. So that's our answer. 0.2. That's the 6th term of this geometric sequence. All right, moving on. Number 18. Given the geometric sequence where a sub 1 is 2 and the common ratio is 8, what is the domain for n? We've already talked about the domain of arithmetic sequences. And if you remember correctly, it doesn't change, right? The domain, we said n is the term number. So you can have the first term, the second term, the third term. Can't have a 0th term, can't have a negative first term. Well, just because it's an arithmetic sequence, this doesn't change. A geometric sequence works exactly the same way. We still can't have a 0th term. We still can't have a negative first term. When it asks for the domain, you're automatically looking for n is greater than or equal to 1. Next question, same thing. Different sequence, but what's the appropriate domain for n? Which of the following, this is which of the following values for n is in the domain? Can we have a negative first term? No. Can we have a first term? Yes. Can we have a 0th term? No. Or they all are, all of the above? No. We can only have a first term. We can't have a 0 term. We can't have a negative 1 term. Oh, what's the sum? We're in lesson 4 now. So we need our geometric series equations from our notes. Oh, a minus 1 is part of that. What is the sum of the sequence if there's 7 terms? Okay, this one uses the first term and last term. This one uses the first term twice and the common ratio. We do not have the 7th term, so we cannot use this one. We can use this one, but we need to find the common ratio. Remember, if we don't know the ratio right off, divide going backwards. So let's divide 50 divided by 10. You probably know that one real easy, but we just want to verify. So that's 5. Let's check it again with 10 divided by 2. Just divide by the number in front of it. 10 divided by 2 is also 5. So this is our common ratio at 5. So let's use this formula. 7 terms equals the first term, which is 2 minus 2 times r to the n. R is 5 and n is 7. Same, it's not n minus 1 this time, it's just n. all over 1 minus r. All right. Let's see. The bottom is going to be -4 because 1 minus 5. Let's see what the top is going to be. 2 minus, parentheses, 2 times 5 raised to the 7th power. So that is going to be -156,248 divided by -4. Divided by -4. So our answer is the sum is going to be 39,062, or that first choice right there. Perfect. It's all falling into place, guys. Okay. 21. Same type of problem. More practice. What's the sum of this sequence? So again, we got to divide backwards to find out what's the common ratio. 36 divided by -6. Probably know that one. It's -6. And -6 divided by 1 is also -6. So our common ratio is -6. So using the same formula again, 7 terms. So again, we want S sub 7. We want the first term, which is 1 minus 1 times -6 to the 7th over 1 minus -6, because our R is -6. So 1 minus -6. So the bottom is going to be 7, right? Because 1 minus a negative is adds. And we need to figure out what 1 minus, well, that's nice. 1 times -6 to the 7th is just -6 to the 7th. So let's see. 1 minus -6 to the 7th power. So this is 279,937. So we just have to divide that by 7. And did we do that right? Ah, there's our selection right there, 39,991. All right, getting to number 22. What is the sum, the series, 7-term geometric series? The first term, a sub 1, is -6. The last term, a sub 7, common ratio, -4. Okay. So that allows us to use this formula because it uses the first term, last term, common ratio. So if we want to know the sum of the 7 terms, a sub 1 is -6 minus the last term, which is -24,576 times the common ratio, all divided by 1 minus the common ratio. Okay, this is where it gets easy to make a mistake because we've got a lot of negatives in there. So we got to work through these one at a time here. Let's do -6 minus, and let's calculate what those are in parentheses. Just to take this a step at a time and not get messed up with all these negatives. So we want -24,576. Negative. Times -4. So that's going to be a positive 98,304. It's going to be divided by 1 minus -4. That's going to be a positive 5. All right, so let's take -6, or -6 minus 98,304. So that equals -98,310, and then divide that by 5. And let's see if that is one of our choices. It is right there, 19,662. Oh, but wait, that's a negative. I don't want to choose the positive one. Negative 19,662. Again, almost made a careless mistake. We knew what we were doing, though, so we feel good about that. All right. Let's see. This one, we have the first term and the last term. What's the sum of a sixth term when we have a sub 1, a sub 6? But this time, they did not give us the common ratio. They gave us that last time. It's negative 4. And we need the common ratio to use this formula. So we're going to have to calculate the common ratio first by working backwards using our geometric sequence formula. So let's see, if a sub 6 is this is a sub 6. So that's going to equal 1, 2, 4, 0, 0, 2, 9. And that equals a sub 6 would equal the first term common ratio raised to the power of n minus 1. The first term times the common ratio raised to the power of n minus 1. And since n is 6, here's the formula we can use to solve for r. So divide both sides by 21, which will cancel out and just leave r to the 5th power on this side. But we need to do the math here. 1240029 divided by 21. So this is 59,049. That's r to the 5th power. So to find what r is, we got to take the 5th root of both sides. So r equals, I can hit the shift, and this has a y root of x. So if I click that, it'll ask me what root I want. I want the 5th root. Oh, so that's 9 to the 5th power. 9 to the 5th power is 59,049. All right, now we have our common ratio of 9. So we can go back and use our formula that we used up here. So for the 6th term, s sub 6, we take the first term, which is 21, minus the last term, which is really big, 1,240,029 times the common ratio of 9 and divide by 1 minus the common ratio, 1 minus 9. So we're going to be dividing by negative 8. So let's calculate what is 21 minus 1,240,000 times 9 here. Let's see. Okay, so 21 minus parentheses 1240029 times 9, close the parentheses. So that equals negative 11,160,240. And we're going to divide that by negative 8. Divided by negative 8. 1395030 right there. Ah, falling into place. All right, let's go to number 24. Find the sum of a finite arithmetic sequence. Oh, wait a minute. 8.06. I think, if I remember correctly, 8.07 we did not do. We skipped that lesson. There are no questions on the test. I took this off the test. So there shouldn't be any questions on this either. So, all right. That's a whole sheet we could just toss. So that takes out a few questions. We're almost done then. So which sequence is modeled by the graph below? The first term is 2. The second term is 2. The third term is 2. The fourth term is 2. Well, what's the common ratio? 1 because it's just multiplying by 1 each time. This is not a geometric series. This is a line, well, except for we're not connecting it. So 2 is the first term. Oh, yeah, here you go. 2 is the first term. The common ratio is 1 and be n minus 1. It's not adding those. It's not 2 to the n minus 1. It's that one. They kind of tricked us. It's not really a arithmetic or geometric. It's the same number every time because the ratio is 1. If it doesn't change, look for the one that has the ratio of 1. All right, number 30. Which sequence is modeled by this graph? First term is 4. Second term is 0.8. Third term is 0.16. This is just representing it graphically, but that is first term, second term, third term, because that's what the domain is. So what's happening each time here? Well, let's see. We can go backwards and divide 0.16 divided by 0.8. It's 0.2. So the common ratio is 0.2. Let's double check that. Make sure it also works with 0.08 and 4. 0.8 divided by 4. Yeah, the common ratio is 2. So the first term is 4 and the common ratio is 2. So we need the formula that shows that. That's got a common ratio of -5. Now, 0.2 is the same as 1/5. 1 divided by 5 is 0.2. So that looks right. This is a 5, and this has got them backwards. The first term is not 1/5. So by process of elimination, if you couldn't remember 1/5, the first term is not 1/5. The first term is not 0.4 either. So this is our answer. All right, just 2 problems left. What is the common difference for the sequence below? Well, that's pretty easy. First term is 3, second term is 5, third term is 7. If you need to write them down on paper, do that. 1, 3, 2, 5, 3, 7. Maybe that confuses you. Just write down the terms. First term, 3, 7. So when we look at that, oh, well, the common difference is obviously it just adds 2 each time. That's very, very simple. They just gave it to you in a graph to see if you could figure out that this is just this sequence. All right, here's the last problem of the practice test. What is the average rate of change? That's what average rate of change means. Anytime you see average rate of change, you should think slope. Well, this is a graph. We could do rise over run. This goes down 1 over 2. Down 1 over 2. Down, rise over run. Rises -1 each time, -1, +2. -1/2 is the slope. Average rate of change. And that's it. That's all of our problems. We've done the entire practice test. So let's go back here. Let's see. I got to turn in the practice test before it lets me take the test. So I'm just going to throw an answer out there and move on. I'm going to turn it in with all those answers. So we've done it on paper. We're okay. And we don't care about a practice grade. Hey, and I got that one right. Just guessing. So, hey, I got a 3. Let's go look at the test now. The first part of the test. Oh, I gave you 2 attempts. Man, I was generous. All right. I normally don't have 2 attempts on the test, but if you bomb it the first time, there's actually a second attempt built in. So this should be the same type of stuff we just did on the practice test. What's the 24th term? Here's the 1st and 9th. So we did some problems like that. Given this sequence, what's the domain for n? Please don't miss the domain. We talked about that multiple times. What is the sum? The sum of this if there's 22 terms. Here's the first, second, and third term. If we add 22 terms together, what's the answer? What is the sixth term where here's the first and fourth term? Now, remember, your questions may be different because it randomizes questions, but they will be the same. You may just have different numbers for whatever. A1 is 2, common ratio. What's the domain? There's another domain question. That should be 2 gimmies right there. If there's 8 terms, what's the sum of the sequence? What's the sum of a 7-term sequence? If here's the first, last, and common ratio, that's nice when they give you the common ratio. Which sequence is modeled by this graph? So you got to pick the formula that makes it. Remember, you can always go to Desmos and look. Here's the sequence graph below. What's the average rate of change between N1 and N3? What's the slope between the first term and the third term? Slope, rise over run between the first term and third term. That's what it wants to know, just between those 2 terms. Ignore term number 2. We don't care about term number 2. It wants to know the slope between the first term and the third term. That's all you have to look at. What is the slope between those terms? And that's it. 9 questions. It's just 9 questions. All right, so that's the first part. Yeah, leave. I know I haven't done it yet. Let's look at the part 2. Part 2 has 4 questions, and these are the ones you show your work. Jeff is designing the seating arrangement for a concert in his high school theater. Each row must have 5 more. Oh, common difference. 5 more plus 5 than the row before it. And the first row can have 12 seats. There's A sub 1. And you're trying to figure out how many seats are going to be in row 25. So first solve that. How many seats are row 25? And then what equation can he use to predict the number of seats in a row? So in other words, what's the arithmetic sequence formula for this situation right here? Here's another one, saving for a cruise. He's got S of X equals 102. That's how much money that he has in the bank. If he works around, he can make extra money this way. Here's his ratio, or his difference, pardon me. This is a difference because he's going to make $8. So this is arithmetic sequence. So he wants to know how he can create a function that combines the 2. How would you combine the 102, which is what he starts with, and the 8 times x plus 02, which is more money he can earn? Would you multiply those, add those, subtract those? How does that work with an arithmetic sequence formula? Here's where he's playing a game. He can create 1.13 times as many villagers every time he creates a new village. He has 4 villagers to start with. So how many villagers can he create with 17 towns? So if you want 17, how many is he going to have in the 17th? And then what equation would you use for that? Show your work. And here she's got $103, which is this function. She can make interest with this function. And when you combine them, it's this. So the whole thing it wants to know is, what is this function? Explain what this new function means. If you have g of x equals 103 times 1.03 x minus 1, what does that give us? When you put in x in there, what does that function even tell us? That's what that's asking. 4 questions. That's it. All right, now let me emphasize. Hold on just a moment. Let me emphasize on that part 2 with those 4 questions. I was just grading a test this week from my Algebra 2 and had those show your work problems like that. And I had a student that knew what formula they were doing. They showed their work. They put the formula, then they substituted in the numbers from the formula, and they were doing the calculations, just showing the calculations. And right at the very end, I think they typed it wrong in the calculator or something, because they had it all written down wrong, and then they gave me an answer that was wrong. So they typed something in wrong in the calculator. Worth 10 points. If they had just given me their answer, I'm not going to show them my work. Answer. They'd have got 0 points because the answer was absolutely wrong. but I gave them 9 out of 10. They got 9 because they showed me their work. They used the correct formula. They substituted the numbers in properly. They did the steps properly. Just the very last thing, they punched something wrong in the calculator and gave me the wrong answer. So I can't give them 10 out of 10 because they got the answer wrong. But I can give them 9 out of 10 because they knew what they were doing. Like I said, if they would just give me their answer and no work, they'd got 0 out of 10. That's a big difference, getting 90% compared to 0%. You want to show your work. Multiple choice questions, all or nothing, 100%, 0%. You want these type of problems so you can get at least partial credit. And if you're lost, you're like, I don't even know how to do this, do what you know. I think it's this formula. And I think I'd put these numbers in and do the, and so, okay, maybe you get 6 out of 10 because, okay, well, you kind of knew what you were doing, but you didn't really know it. But that's better than 0 points. So try, put some formulas down, put what you know, work it as far as you can. Don't just, oh, no, I don't know. I'll just leave it blank. You've got all these formulas. If you don't have all these formulas in your notes that we've used, you should go back to the lesson summaries of each lesson and write those down on paper. Have them all on one page. We have all my formulas. There's the arithmetic sequence. Here's the 2 formulas I can use. Here's arithmetic series. Here's geometric sequence. Here's geometric series. And I would have all those formulas because we used them all at the practice test. We went through and said, oh, this formula, oh, that formula. And it made it real easy when we had the formulas right there. So make it easy on yourself. Prepare for the test. You should have those written down already from going through the lessons each week because we did those notes live. So all those notes I pulled out there were ones we did in class. So you may already have them. So, okay, guys, we've done the practice test. You have the test. So I will let you go get started on that. If you got questions, this is a B-Day Friday. So I will be here Thursday and Friday. So if your grade is below 70%, I'll see you Thursday and Friday, which I don't know that hardly anyone. I think some people that didn't turn in the last stuff may be below 70%. So if you haven't, turn in that last week's stuff. But anyway, go tackle the test. If you have problems, come see me Thursday and Friday. Even if you're having trouble in the test, you can come see me. I may not work that exact problem, but I can help you understand the concept. Help you understand which formula you should be using, that type of thing. So I will help you. So come see me if you need to. Have a great week, guys.